You know, we live our lives surrounded by things, our homes, our offices, the roads we drive on, and we just trust the materials they're made of to keep us safe. But what happens when that trust is broken? What happens when those very materials fail catastrophically? Today, we're going to explore a fascinating potential solution, a class of materials that basically blends the ancient strength of rock with the modern versatility of plastic. And it might just be the key to building a safer and greener future.
But before we can get to the really cool solution, we have to understand the problem. And we're not talking about a small crack or a minor flaw here. We're talking about the kind of catastrophic failure that forces us to stop and question the very stuff we use to build our world.
And that brings us to a really tough question, but it's one we have to ask. Because when we talk about something like materials science, it isn't just theoretical, The stakes can be quite literally life and death. So how could a modern building in a major city fail so tragically?
The answer, unfortunately, is tied to the Grenfell Tower fire in London. The fire spread with just devastating speed, and it was fueled by the building materials themselves, materials that simply weren't designed to handle that kind of extreme heat. It was a brutal, real-world lesson in the failure of modern polymers, basically plastics, when they're put to the test by fire. The source material we're looking at today puts it pretty bluntly. Organic materials, plastics, wood, things like that, they burn. It's just what they do. For real, true fire and heat resistance, you have to look to the mineral world, to rocks. And that fundamental principle is what leads us to a completely different type of material. So if the big problem is materials that burn, the solution seems kind of obvious, right? Use materials that don't burn. And this is where we get introduced to geopolymers. Now, that might be a new term for a lot of us, but the concept is this really powerful blend of geology, the science of the earth, and modern polymer chemistry. Okay, so here's the core idea, and it's pretty cool. Imagine you could take the raw stuff of the earth, we're talking minerals, rock dust, and use some clever chemistry to link it all together into long chains, just like a plastic. Well, that's basically what a geopolymer is. It's an inorganic, mineral-based material that you can mold and shape like a plastic, but it has the built-in strength and heat resistance of stone. Best of both worlds, really. This really lays out the fundamental difference. On one side, you've got the organic polymers that we all know, plastics. Super useful, but they have that critical flaw. They burn. On the other side, you have geopolymers. That geo part is the key. It means earth, mineral, and it's that mineral foundation that gives them their superpower, incredible resistance to fire and heat.
But here's the thing. Being fireproof is just the beginning. The reason this technology is so darn exciting is that the benefits go way beyond just safety. This stuff is a true multi-tool in the world of material science.
Just look at this list. It's pretty impressive. Of course, you've got the exceptional fire resistance, but on top of that, they can form these super rigid, anti-corrosive coatings that can protect things like steel and concrete. And from an environmental standpoint, they have a lower carbon footprint. There are even products called earth-friendly concrete that are made using industrial waste like fly ash, so you're turning waste into something useful. And if all that wasn't enough, they're strong enough to be used in high-tech structural composites. Okay, so that all sounds fantastic, but where's this technology actually being used? Well, the applications are incredibly diverse, stretching all the way from heavy industry to high-tech manufacturing. Let's just run through a couple of them.
In the world of cars and aerospace, this stuff is a total game changer. Think about parts that sit right next to a blazing hot engine, or high-performance brakes. They have to be lightweight, but they also have to withstand insane temperatures and stress. Geopolymers are a perfect solution for that.
You'll also find them in some of the most punishing environments on the planet. There are patented geopolymer formulas that can be pumped deep underground in oil fields, where they have to hold up against immense pressure and corrosive chemicals. I mean, that's a serious testament to their durability.
And now for a really surprising one. The same exact chemistry that lets you build super tough industrial materials can also be engineered to have a controlled, porous structure. And why would you do that? For biomedical uses. Like creating tiny compositions that can deliver drugs in a slow, sustained way inside the body. That versatility is just mind-blowing.
And this shows that these aren't just ideas stuck in a lab. We're looking at actual real-world research projects, like developing geopolymer-based pavement for aircraft runways. It just highlights how this is being taken seriously for critical infrastructure, places where strength and durability are absolutely non-negotiable.
So the main takeaway here is that geopolymer science isn't some fringe theory.
It's a serious, well-established field. And just to give you a sense of the scale of the research, let's take a quick look at the resources you can find from the Geopolymer Institute, which is kind of the central hub for all this.
So they host 24 foundational technical papers. These are available for anyone to download, and they cover everything from the deep dive chemistry to specific industrial applications. And if you want to hear it straight from the experts themselves, there are 11 special keynote videos from some of the leading researchers and engineers in the field. And on top of that, 8 different state-of-the-geopolymer R&D videos, which actually track the progress of this science year after year. So yeah, the body of work here is huge, and it's still growing.
So when you put all of this together, you have the problem, you have this really elegant solution, and you have this huge range of applications. You just have to step back and ask yourself, what does this actually mean for our future?
It means we have a real pathway to a world that's built differently. A world where buildings can resist fire instead of fueling it. A world where making concrete has a much smaller carbon footprint. And a world with advanced composites that let us keep pushing the boundaries of technology.
So I'll leave you with this final question. Geopolymers offer this really compelling vision for the future. It's a vision that looks back to the fundamental properties of minerals to solve some of the most urgent problems of our modern world. The science is there. The potential is obvious. So the only real question left is, are we ready to build with it?